In this video, we're going to look at some examples where we are finding the equation of a line. We are given several different situations in which we're asked to do this. Sometimes we're given the slope of the line and then given some sort of point. Maybe it's a random point or maybe it is the y-intercept. Sometimes we're given 2 points and we have to find the slope in order to write the equation of the line. And then sometimes we are given a point and either a line that's parallel or perpendicular to the line that we want to get an equation for. Okay, so let's take a look at an example where we are given the slope and the y-intercept of the line. Okay, in our first example, we're going to find the equation of the line with a slope of -4 and a y-intercept at 0, -1. Okay, so the first thing that we need is an equation or a formula that we can put these two things into so that we can get the equation of a line. Now the slope is commonly known as little lowercase m, and our y-intercept could be our b value, or it could also be our x sub 1 and y sub 1 if we want to use the point slope form. But let's do this the easy way. And since we're given the slope and the y-intercept specifically, let's just plug those two things into slope-intercept form. Okay, y equals mx plus b. Now, we'll take this slope right here at -4, and we're going to plug it in right here. Okay, where we have that m. So y is equal to -4x. And then we'll grab b, which is going to be -1, and we'll plug that in right here. Okay. So since it's -b, that's going to be -1, and then I don't have anything else to do. Okay. I don't have to rewrite anything, simplify anything. It's written in the form we want it in, so we're done. All right, let's try another one. All right, this time we're going to find the equation of the line with slope 1/2, passing through the point 2, 6. Okay. So we've got an m with slope, and then we've got an x1, y1 with our point. Okay, we can't use slope-intercept form because I don't have the y-intercept. I know a point, but I don't know the y-intercept. So what I can use though is point-slope form. Y minus y sub 1 is equal to m times x minus x sub 1. I have everything I need here. We'll leave the y and the x alone, and we just plug in for everything else. Y minus 6 is equal to 1/2 times x minus 2. Distribute your slope. Okay, you'll do this part first, and then once this is simplified, take your -6 and move it over. So y minus 6 is equal to 1/2 x minus, what's 2 times 1/2? That gives you a 1, okay? Then we add 6 to both sides. Y is equal to 1/2 x minus 1 plus 6 gives me plus 5. And now I'm in slope-intercept form, and that's how I want to end it. All right, so now that's given us one where we have the slope and some random given point. Let's try one that has 2 points. Okay, find the equation of the line passing through the points -1, 3 and 2, -1. When you have 2 points like this with no slope, what we need to do first is find the slope by using the slope formula. And then we'll take that slope that we calculate and we'll plug it and one of these 2 points into the point slope form that we used just a second ago. Alright, so let's first find our slope. M is equal to, and I didn't label these, but why don't we let this be y sub 1, and I'm sorry, x sub 1, y sub 1, and this one we'll let it be 0.2. So I'm going to have -1 minus 3 over 2 plus 1. So, let's see. continue to come down here. That's going to give me negative 4 over 3. So I get negative 3/4 for my, my slope. Okay. And then you can pick either point you want. I'm going to go ahead and use that first point that I've already got labeled x1, y1 to plug in for my two variables there. So I'm going to get y minus y sub 1 would be 3 is equal to negative 4/3 times x minus x sub 1. So y minus 3 is equal to negative 4/3 x minus 4/3. And now what we have here is a little fraction that we're going to have to deal with. So let's go ahead and change 3 right here so that it has the same denominator as the number I'm going to need to put it with. I'll tell you what, we'll go ahead and move it over first. I think that might be a little easier to see. So add 3 to both sides, as is. Okay, and then if I want 3 to be the denominator, what I'm going to have to do is multiply my whole number 3 by 3 over itself, so that I don't change the value of the number, but I do change the denominator so that they match, and I can combine them. Y is equal to negative 4/3 x, and then I've got negative 4/3, and what's going to be, when we multiply these two together, 9/3, right? So negative 4 plus 9 gives me positive 5/3. And there's my answer. Okay, so now we've seen an example where we're given 2 points, and we have to calculate our own slope from that. All right, take a look now at what we do when we have parallel lines. Okay, find the equation of the line that's parallel to y equals 1/2 x plus 1 and passing through the point 2, 4. Okay, again, we don't start out with slope. It's not handed to us. So what we have to do is take what we know and try to find slope. I don't have 2 points, so I can't use the formula. But what I do know is that it is parallel to this line right here. Okay, parallel lines have the same slope. So first, find the slope of this line. What's that going to be? So it'll be coefficient on x since it's in slope-intercept form, so that's 1/2. Since parallel lines have the same slope, 1/2 is what I will use also. We'll make that x1, y1. So y minus y sub 1 is equal to m times x minus x sub 1. Distribute the 1/2. 1/2 x minus 1 is what we get. Scoot up a little bit. Now move the 4 over. So y is equal to 1/2 x. If I add 4, I get plus 3. Okay? So you can do it this way too, where you're not given slope, but you find it because you know the line that's parallel to it. And parallel lines do have the same slope. You can do a similar problem with a perpendicular line, so let's take a look at that. Okay, so let's take a look at this one. Find the equation of a line perpendicular to 2x minus 2y equals 7. That's the equation of a line in general form. And passing through the point negative 3, 1. Okay? So again, we have to find our slope for the line equation that we're given. This time we are perpendicular to this line, so we will take the opposite reciprocal. Okay? The opposite reciprocal to what we get for the slope of that equation right there. So let's work on that for just a second. I'm going to do this in red so we can kind of separate it from the rest of our work. If I isolate y, 2y is equal to negative 2x plus 7. And I apologize, I'm running off the screen right here. Sorry about that. Hang on a second. Let me pull that over just a little bit so it's a little nicer looking. 2y is equal to negative 2x plus 7. Okay. Divide through by 2, and y is equal to negative 1x plus 7/2. Now, the 7/2 I'm not worried about. What I need to know is what is the slope there. So the slope of the line that's perpendicular is m equals negative 1. Okay. The slope that we'll be using will be the opposite reciprocal of that, which is positive 1. Okay, opposite means opposite sign, reciprocal means flip it. If you flip a 1, you still get a 1. So we wind up with a positive 1. And then we have our point, x1, y1 right here. Negative 3 is x1. Positive 1 is our y1. We plug into our formula. Y minus y sub 1 is equal to m times x minus x sub 1. Distribute the 1. We're not going to really have to do anything there. And then we will move the 1 over. Add 1 to both sides. Y is equal to x plus 4 is what we wind up with. Okay, so this video has covered one of each different problem that you might be asked to find an equation for. Okay, what you'll notice about each and every one of them is you have to have the slope and a point to be able to work it. Okay, so if you're not just handed slope, in all these you are just handed a point, or at least one point. But if you're not just handed slope, you do have to have a strategy for finding it, either by the slope formula, or if it happens to be parallel or perpendicular, you can work it like we've worked these two. Okay?